Let's check this problem. The first part is the flux density D is given and you are asked to calculate the flux crossing the portions. So to calculate flux, you know that flux that is equal to surface integral of D dot ds. So to calculate flux, you have to identify D, you have to represent ds, take this dot product and take the surface integral. Okay, so first thing is flux crossing the portion of z equals 0 plane. So first trying to identify ds. ds is equal to, it is z equals 0 plane. So what will be the coordinate system? Z is there, an angle is there, radius is there. So this is cylindrical coordinate system. It is a cylindrical coordinate system. We know that the coordinate system is rho phi z, and in this problem instead of rho they have given r. So we can rewrite it as r phi and z. Don't consider this as a spherical coordinate system because of the coordinate r, because you can use it in any way, rho or r. What we are checking is one radius or that distance component, one angle and z. So that means it is cylindrical coordinate system. Whether it is rho or r, it is cylindrical coordinate system. In the problem it is given as r. So instead of rho, here in this problem we take it as r phi and z. Okay, so ds is z equals 0 plane, means that is an r phi plane. That's why we say it is a z equals 0 plane, because z is a constant. So r and phi are varying. So it is an r phi plane, and because of that the unit vector normal to that plane is az. In r phi plane the unit vector normal to it is az. Okay, so this much we know. So how you can define ds? ds will be r phi. So dr into r d phi into unit vector az. That is equal to r dr d phi into unit vector az. Vector d dot ds, taking the dot product means z component you are multiplying. Okay, so the first part you need not take, and here psi will be minus sine phi divided by 3r into r dr d phi. Okay, you are just multiplying the z components of d and ds. Why? Because ds is having only z component and r is getting cancelled, and you are taking the surface integral. So this will be minus sine phi divided by 3 dr d phi. And now you are taking surface integral. You are integrating with respect to r. R is r less than or equal to a. So r will vary from 0 to a, and phi is varying from 0 to pi by 2. So minus 1 by 3 constant is taken outside. Integral of sine phi, that will be minus cos phi. That is minus cos phi within the limits 0 to pi by 2, and dr on integrating you get r from 0 to a. So this will be minus a by 3 into minus 0 minus 1. So that will be cos 90, that is 0, minus minus 1, that is plus. So because of this you get the value as minus a by 3, and this is the value for the flux. So minus a by 3 Weber. So that is the answer to the first part of the question. In the second part of the problem, we can just note it. It represents two regions. Region 1 where x is less than 0, and region 2 where x is greater than 0. Okay. And mu r1 is given as 3 and mu r2 is given as 5. And h1 is given as 4ax plus 3ay minus 6az. So here you have to calculate H2. So you know that you have to apply the boundary conditions. And boundary conditions coming are H1T is equal to H2T. Tangential components of H1 and H2 will be same. H1T and H2T will be same. They are equal. H1T is equal to H2T. And normal components of B1 and B2 will be same. B1n is equal to B2n. These are the two boundary conditions that you can apply. Now, what you have is H1. H1 is equal to 4AX plus 3AY minus 6AZ. So here you know that the normal component, normal is AX. This is the normal vector because the boundary is separated by x less than 0 and x greater than 0. So that means the unit vector will be AX. Okay, so here x greater than 0, here x less than 0. So the unit vector will be AX. So the n component or AN will be AX. So based on that, how you can write H1n will be equal to 4AX. H1n will be the x component which will be 4AX. So H1t will be the rest of the part because it is H1 is equal to H1t plus H1n. So when you get the normal component, the rest of it will be tangential component. So H1t will be 3AY minus 6AZ. So now we got H1n and H1n and H1t. Now H2t, you know H2t is equal to H1t. So that will be equal to 3AY minus 6AZ. So you got the tangential component. Now how to calculate B1n? This will be equal to mu 0 mu r1 into H1n. H1n here you have it as 4AX. So this will be mu 0 into 3 mu 0 into 4AX. It will be 12 mu naught AX. This will be B1n component. So from this, how you can get H2n? H2n will be, so this will be equal to B1n. This is equal to B2n also. So H2n will be B2n divided by mu naught mu R2. So this will be 12 mu naught AX divided by mu 0 into mu R2 is 5. So you will be getting 12 by 5 AX. This will be equal to 12 by 5, that is 2.4 AX. So from this, how you can write H2? H2 will be equal to, it is the tangential component, sum of tangential component and normal component. So that will be 2.4 AX plus 3AY minus 6AZ. So you separately calculated normal component, you separately calculated tangential component and you added the two to get the total vector. So now you have H2. Question was, first part is over, this find H2 and second is angle it makes with the normal. So now what you have to calculate is you have to find the angle it makes with the normal. So for that, vector h, say any vector, say vector h dot an, that is a unit vector normal to it, h dot an will be equal to modulus of first vector. The second vector, the magnitude is 1 because it's a unit vector, into cos theta, where theta is the angle which the vector makes with the normal. So here you are asked to calculate this theta. So cos theta will be equal to vector h dot an divided by modulus of vector h. Vector h dot an means here the normal component is ax. So you are taking the x component, that will be 2.4. You are taking the x component as here an is equal to ax. Okay, so 2.4 divided by modulus of vector h, that is square root of 2.4 square plus 3 square plus minus 6 the whole square. magnitude of any vector is square root of ax square plus ay square plus az square. So it is square root of 2.4 square plus 3 square plus 6 square. So 2.4 divided by, on calculating this, you will get 7.125, and that will be equal to 0.337. So the angle it makes with the normal, that is theta, is equal to cos inverse 0.337. That will be equal to 70.3 degree. So this is the answer. So the second part, if first they asked us to calculate H2, H2 is this value, and angle it makes with the normal is theta, that is 70.3 degree. So this is the answer.